Here are my dogs. They're ready to learn. Right? They're up with me, studying Unit 5. They want to do good on the test. I said if they do good on the test, they both get a bone for being good boys. All right. So let's get back to that math. That's what's important. All right. So given ABC is the following points. So what we're going to do first is just plot this triangle right here. And again, lengthy notes, but it's okay because this is how we're studying for the test and how we're preparing. I like to kind of make reviews really long or longer than normal, so students have too much to study, just so they're more prepared. I don't want to give them not enough to study and then they don't know what to do. All right. So I went ahead and just plotted those points. All right. A is -4, 1, so left 4, up 1. B is right 5, up 3, and C is right 3, down 5. So now we're going to connect it. All right. Is a triangle scalene, isosceles, or equilateral? Is it a right triangle? So we're going to do the distance formula for one side, just good to practice it, and then we're going to use Pythagorean theorem shortcut for the other sides. So AB, giant square root, x sub 1 minus x sub 2 squared, y sub 1 minus y sub 2 squared. All right, remember it's good to have the squares and all the details, like don't forget the squares, the plus, the giant square root, the minuses. All right, hopefully we're starting to get quite used to the distance formula. All right, so, and I'm also going to label my coordinates A and B. So I'm going to call A x sub 1, y sub 1, B is x sub 2, y sub 2. All right, so then it's just a matter of plugging in the points the correct way. Where A, so -4 is x sub 1, 1 is y sub 1, 5 is x sub 2, and 3 is y sub 2. All right, so we want to make sure we plug in everything correctly. I'm going to get -4 minus 5 squared plus 1 minus 3 squared. All right, so then it's from here just following PEMDAS, parentheses. All right, so I'm going to do -4 minus 5. I'm going to get -9 squared. 1 minus 3, -2 squared. All right, so I did parentheses. Now I'm going to do exponents. -9 squared. Negative times a negative is going to give me positive 81. -2 squared gives me 4. I'm going to get the square root of 85. I'm going to plug that into a calculator. About 9.2 with a little bit of rounding. Cool. All right. So AB has a length of 9.2-ish. All right, distance formula is great, but something else we can use is the Pythagorean theorem shortcut. All right, and recall, that's when we create a right triangle and use a squared plus b squared equals c squared. All right, so 1, 2, 3, 4, 5, 6. So I'm going to call this side A is 6. 1, 2, 3, 4, 5, 6, 7. So I'm going to call B 7. And then this is lowercase c. So remember, we have the Pythagorean theorem shortcut. So this is defined side capital AB, or except AC. We use a squared plus b squared equals c squared. We're going to do 6 squared plus 7 squared equals c squared. 36 plus 49 equals c squared. And we're going to get 85 equals c squared. Oops, what happened there? So we're going to get c equals the square root of 85. So c is going to be about, let's calculate that really fast. Oh, we already did a brain fart. We had 9.2. We did that up there. So we have two sides of 9.2. Interesting. Alright, I wonder if this last side is going to be 9.2-ish as well. Alright. This last one, we're going to use Pythagorean theorem shortcut again, because I think it's a little quicker and easier. I like to know the distance formula, kind of have that practiced a lot. B is going to be 8, and we'll call this C. So again, we're just going to do, this is for side CB. We're going to say A squared plus B squared equals C squared. In this case, A was 2, B was 8. We're going to get 4 plus 64 . So C equals the square root of 68. So we can already tell it's not going to be an equilateral triangle. With the square root of 68, it's about 8.2. Alright, so in terms of sides, classifying this by sides, it's isosceles. We have two congruent sides. Now, is it a right triangle? Well, remember, for a right triangle, we need perpendicular lines. So perpendicular lines, what's so great about their slopes? We need opposite reciprocals for their slopes. So that would look something like, you probably can hear my dogs in the background, where you change the sign and flip. So really fast, I'm kind of running out of room, but like the slope of AC, let's see if we have any perpendicular slopes. Well, we already said it was down 6 over 7. So that's a slope of negative 6 over 7. The slope of BC, we already said was right 2 up 8. So it's 2 over 8, also known as positive 1/4. So those two lines aren't perpendicular. So this angle is not a right angle. And then the slope of AB is up 2 over 9. So I just counted the slopes of all the lines. So notice how none of these slopes are opposite reciprocals, so angles, non-right. And in fact, it's probably acute, but we technically don't know the math to prove that yet. You can tell by looking at it. So it's a non-right isosceles. Whew. All right, that problem's very dense, but I know you guys can do it. All right, now let's do an exterior angles theorem problem. All right. States that the measure of each exterior angle of a triangle is equal to the sum of the opposite non-adjacent interior angles. So reading this, the exterior angle theorem states that the measures of each exterior angle of a triangle is equal to the sum of the opposite non-adjacent interior angles. So that sounds crazy. Basically what this is saying is we got the exterior angle right here, that'd be 20x, that's on the outside. It's equal to the sum of the opposite non-adjacent interior angles. That means you're just going to take these two angles that don't touch it, add them together, and that's what it equals. All right, so all you do is 20x equals 60 plus 7x plus 5, and boom, that's the exterior angles theorem. All right, then you get 20x equals 65 plus 7x after you combine like terms. Then you subtract 7x from both sides. You're going to get 13x equals 65. Divide both sides by 13. And x equals 5. Alright. Now, we're going to have some isosceles triangles problems. It has legs that are 2x plus 4 and a perimeter of 122. If the base is x plus 14 centimeter longs, what is the base of the triangle in centimeters? Alright, so really, let's draw a picture. Alright, sometimes we don't have to draw pictures, they're given to us. Whoa, I tried to draw a triangle, out came a rectangle. Let's draw, there we go. Alright, so it's an isosceles triangle. Let's start with that. An isosceles triangle. That means we're going to have two sides that are the same. Alright, those are the legs. Alright, and it's saying that both legs are 2x plus 4. Alright, what else is it telling me? It's telling me I have a perimeter of 122. Alright, and then it's also telling me I have a base of x plus 14. Alright, so since it told me every side length isosceles, so 2x plus 4, 2x plus 4, a base of x plus 14, and a perimeter of 122, really, all you gotta say is, well, the perimeter is gonna equal all the side lengths added together. So I'm gonna have 2x plus 4, plus 2x plus 4, plus x plus 14. Alright? So again, don't forget the first thing we got to do is combine like terms. So 2x plus x is going to give me 5x plus 4 plus 4 plus 14 is going to give me 22. So just cleaning up the equation. Let's see, now I'm going to get 100 equals 5x. Gotta go all the way over here, divide both sides by 5, and 20 equals x. But remember, we need to read the question. We need to make sure we answer the question. It's saying, what is the base of the triangle in centimeters? What is the base of the triangle in centimeters? So I just do 20 plus 14, 34, and that's what the base is. Base, 34, and emphasize my answer. Cool. This one right here, another isosceles triangle problem, has base angles that are 3x plus 37 and 5x plus 33 to find the measure of the vertex angle. So again, let's draw a picture. Alright. Remember, these are legs. I don't really need to write that down. But these are base angles. And this is vertex angles. The congruent sides are the legs, but we don't need to write that down. But anyways, what it's saying is, well, the base angles, one is 3x plus 37 and 5x plus 33. So remember, the base angles are the ones that are congruent to each other. So since they're base angles, I can say, well, 3x plus 37 equals 5x plus 33. And then just solve from here. So I'm going to subtract 3x from both sides. And I'm going to get 37 equals 2x plus 33. Subtract 33 from both sides. I'm going to get 34 equals 2x. Divide both sides by 2. and 17 equals x. Oops, hold on, timeout. Brain fart, massive brain fart. Massive brain fart. 4 equals 2x. I don't know why I wrote 34. Divide by 2. 2 equals x. And then we got to go ahead and plug that back in. Alright, so we got to do that for the base angles. They should come out to be the same number. So this angle's 43 degrees. Plugging it in over here, I'm going to get 43 degrees as well. Alright, and since vertex angles, they're the non-congruent one, we're going to do 43 plus 43, 86. So it's 94. Alright, so that's the answer. The vertex angle, find the measure of the vertex angle. We're going to write it 94 degrees. Vertex angle 94 degrees. Alright, and then last problem of the video, is it possible to create a triangle with lengths of 7, 54, and 45? Explain why or why not. And remember, this is the triangle inequality theorem. Triangle inequality theorem. Take two smaller sides, add them, must be greater than the third. Alright, so in this particular case we're going to do 7 plus 45 because they're the two smaller sides. That gives me 52. It's less than 54, so it's impossible. And this is the math why. It's just the triangle inequality theorem failed. Alright, the triangle inequality theorem